All right, last one for the day. So 27. For a certain discrete random variable on the non-negative integer, the probability function satisfies the following. Okay, so first of all, let me read it again. For a certain discrete random variable on a non-negative integer, right? So we already know that it's non-negative, that it's going to be greater than 0. The probability function satisfies this. So first of all, they said the probability of 0 is equal to the probability of 1. And they said the probability of k plus 1 is equal to 1 over k times the probability of k. Okay? For k, in this one right here, for k is equal to 1, 2, 3, and so on. Find probability not, or probability of 0. So if k is 1, then the probability of 1 plus 1 is equal to 1 over 1 times probability of 1. And this is saying that the probability of 2 is equal to the probability of 1. Okay, so all of these are equal. If k was 2, then the probability would be 2 plus 1, which is, right, this is 3, is equal to 1 over 2 times probability of 2. Well, this is what we got. But we know what probability of 2 is equal to. We know that is 1, 2 times the probability of not. Now, if we really think about this, every time that we went up from 0, 1, and 2, this right here has to be a multiple of it. So this would be actually, by staying with the rules, it would have been in this and this. You know what that looks like? 0 times 1 times 2 is a factorial. Voila, we have a factorial there. Well, that's useful. We needed to know that factorial. All right. So now we know that I would say that the total probability is equal to 1, and this right here starts at 1. So then we know that this right here is equal to right, that as this is 0, this is 1, blah blah blah, it's going to continue to be such a thing. And really what we know is this, that this is what? What is this? What is this? This is factorial, but remember, it's I minus 1. I minus 1 is 1 back from what we want. We also can do this. We know this is a multiple. And with careful eyes, we know this is really an eye as well. That it's just going to be a multiple of it, because this is a sum, and so as we sum them, we basically want to know what that is. And we know what this is. This is an identity of E raised to the 1, right? Because this is what we have here. So this is really P naught is equal to 1 plus E1. It's E1. Or how the book has it, or the question has it right now, has it as P naught 1 plus E. Whatever. This is all equal to 1, and we can backwards solve for P naught, right? Which would just be 1 over 1 plus E. And they try to hide it again, right, by raising it to the numerator, but we see it's there as at C. So knowing that we're going to basically sum these up and how these things are multiplying, I mean, we know what's going on, we can find the answer.